Hello and welcome to this lesson video. We'll learn about cut-to-fill operations and how to visualize them and the importance of balancing cut-to-fill operations. The video covers the shown two learning objectives. So what is a cut-to-fill operation? Cut-to-fill operation is the process of moving the soil within the construction site from a cut segment to a fill segment to reach the desired profile grade. CTF does not typically include hauling the soil to or off the site because importing and exporting the soil beyond the site boundaries imply different operational and cost implications. To plan CTF operations, you need to learn how to visualize the topology of the site before and after construction. You need to construct your own 3D model of the site so you can understand the project scope and visualize the CTF operations. Let's practice this in the next slides, how to use the project profile and section views to visualize the project and its CTF operation. Here is a simple profile view of a roadway project where the road goes through two valleys with a lower existing elevation and a hilly segment with higher existing elevation. Section view 1.1 shows the road cross geometry in the valley segment. And you can see here we need to fill the road embankment as shown. Section view 2.2 shows the road's cross geometry in the hilly segment, where you can see that you are excavating the soil to reach the road level. You can notice that only one section was given to provide the cross-section geometry for both valley fill segments. That's fine and actually typical in earthwork projects because the purpose of these sections is not to provide the cross geometry dimensions. Otherwise, you will need to provide a section view for every meter or foot as the geometry changes over the length of the project. The cross-section view usually is given with variable dimension, with the main purpose is to show the general geometry of the section, its slope, and layers. I will run in the next slide a video of me trying to visualize this project using sticky sand. Let's check it out. So here's a container with sticky sand that I shaped to match the existing natural grade of the example project. Let's see how it looks like. So let's look at the natural grade surface from different angles. You can see and match two valley segments and the hilly segment that we saw in the drawings. Now let's see how the grade should be in the out of plane direction. Let's move the camera to different angles. You can see that there is some slope downhill towards the camera or the near side of the container. This is because the section views show for both segments some slope in the direction of in the existing natural grade. Now let's use this ruler to visualize the road. Imagine it's the road asphalt. I will slide the ruler to the position where the road level should be. I will also use it to cut any soil that goes on top of the soil or the roller, kind of excavating the soil to reach the road level. So here's our first excavated soil. Let's cut more soil so I can reach the cross-section geometry of the road in this segment. I will cut the soil to have the slope hill slides along the road to maintain the soil stability. We don't want to have the mudslides in the road. You can see we're done with the only soil excavation in this project. And after putting the roller, you can clearly see what we need to backfill below the road in the two valley segments we have. But where do we bring the soil to backfill these two segments? It makes sense to use the soil we just excavated right. So let's use it for the first backfill zone. Here I'm doing my best to match the cross geometry of the road in this segment by reaching the road elevation and constructing the embankment slope on both sides. I was doing my best there, so don't judge me. Now let's move to backfill segment 2 and see how much we need to fill and where to bring the soil for this fill. But wait, this is the only excavated soil left after we finished fill segment 1. What should we do? That's a good question. So no need to panic. We will borrow soil from outside of the site to finish the second fill segment. Just imagine this far corner of the sand container is a quarry where we will borrow the soil. So here I'm working on pulling the soil from the quarry to the fill segment and trying my best to reach the road elevation and match the embankment slope shape. Now we completed the CTF operation. This is just a simulation of the real life operation, but we visualized the project before and after the operation and also understood our earth moving flow. So we'll need to borrow outside soil for the second segment. The first fill segment was completely covered by the soil from the only cut segment of the project. So this sticky sand exercise is just an attempt to show how to visualize earth moving and CTF operations. Over time and with experience, you should be able to do such visualization exercise mentally without the help of a container filled with sticky sand, right? Now it's your turn to go and visualize it on your own. Here is the same project that we covered before in the previous lessons. It will be a great exercise for you to visualize this project the same way I did. You can go to any park nearby or nearby beach and you will find plenty of sand there. No excuses. I can give you a little hint. Make the sand moist before you start the exercise. It will make it easier to shape it the way you want. Now let's define a more specific objective for CTF operations, which is trying to balance them. Balancing earthwork operations is our way of trying to achieve the number one goal of construction: reduce cost and waste. It's very common sense to try to match the soil you excavated to the areas that need to be filled, instead of hauling the excavated soil to a dump site and then buying soil from a quarry and hauling it to the site. If the on-site soil satisfies these geotechnical specifications, why not recycle the excavated soil? From the sticky note exercise video, we see we have two balanced CTF operations or holes. Even with our due diligence and effort to balance the CTF process, we still had a big part of the project not balanced internally, and we had to borrow soil from an outside source. This is a profile of another example project, and you can see that there are three balanced CTF operations here. Actually, there are four. Also, you can see that a fill segment was not balanced with any cut segment. So this is a borrow project where we will need to buy and haul in soil for this last fill segment. So in summary, contractors do their best to balance their earthwork operations, reduce unnecessary hauling, and squeeze costs. But it's not common to have perfectly balanced earthwork project. There will always be some excess excavated soil that needs to be off-hauled to the dump site, or a shortage of fill soil that needs to be hauled from a quarry. For real roadway projects, we don't use sticky sands. We use mass diagrams that can help a lot in visualizing earthwork project and planning their balanced CTF operations. So stay tuned to the next video to learn more about mass diagrams. Alright, I hope you enjoyed this video about how to visualize and balance cut to fill operations. Take care and cheers.